Assalamu alaikum. With you, Madam Derkawi. In this presentation or this lecture, I will present one of optimization methods or one of optimization algorithm, which is the meta-heuristic, and it's entitled simulated annealing algorithm. It is used to solve an optimization problem. So the lecture plan is first we will see what is the context of this presentation. That means we will see what is the optimization, the principal concept of optimization, the algorithm for solving an optimization problem. Secondly, we will see or we will talk about the meta-heuristic simulated annealing methods. So I present a little historical and the principle of the metropolis methods, the principle of the simulated annealing methods, the area of use of simulated annealing methods, and the artificial intelligence and simulated annealing. And we will see an application example and its implementation of the algorithm, the implementation of the algorithm, which is the simulated annealing methods, with the Python language. For the optimization, or for the definition of optimization, I will read this Euler quote. Euler said, nothing takes place in the world whose meaning is not that of some maximum or minimum. That means the optimization has for objective to detect a maximum or minimum of a problem. So what is optimization? Optimize and optimization derive from Latin optimus, meaning best. Optimization starts its gradual perfection in middle of the 19th century, when it was derived from optimize, word first used in the early part of that same century with the meaning to make the best or most of. In basic application, optimization refers to the act or process of making something as good as it can be. In the 21st century, it has seen much use in technical contexts having to do with attaining the best possible functionality, as in network optimization and search engine optimization. Like the words optimum and optimism, which refer respectively to the amount or degree of something that is best or most effective, and to a feeling or belief that good things will happen in the future. This definition is from the reference 10, which is listed in the last of the presentation, or this PowerPoint presentation. So, optimization is an act, process, or methodology of making something, such as design, system, or decision, as fully perfect, functional, or effective as possible, especially the mathematical procedures such as finding the maximum of a function, the maximum or minimum involved in this. What is optimization problem? maximizing or minimizing some function relative to some set, often representing a range of choice available in a certain situation. The function allows comparison of the different choices for determining which might be best. Common application that minimal cost, maximal profit, minimal error, optimal design, optimal management, variational principles. What is the context? So, our objective is to solve an optimization problem. So, we want to solve numerically an optimization problem. So, we are in the case of criterion or single criterion. That means we have one objective function, a maximization or a minimization. We can have two cases: the problem optimization without constraints, or an optimization problem with constraints. This is a graphical illustration of this context. In this figure, we have the graphic of the optimization problem without constraints. So we have this in the blue color. It's the area space. We contain the different point of the function, which is minimization. In this illustration, we have the minimization case. So, algebraical writing is the objective function min of the x, and here we have the area of the variable or space of the variable of the space with the different values which the variable x can take. So in this illustration, we have a strict local minimum is in this point, or this point represents the strict global minimum, and these points are local minimums. In the second illustration, we have a OP or optimization problem with constraints. So we have the objective function minimum fx subject to constraints illustrated in the algebraic form with gx is in this equation. So we see in the second illustration that we have restricted the area space. We have only this space with this color, because we have x is in the subset of R degree n. So we see this is the admissible space, and this is not admissible space. So the solution of the same problem with constraints is different from the solution of the same problem without constraint, because constraint limited the space or the area of solution. So in the first illustration, the solution is this global minimum, because it is in the area space of solution, and in the second illustration we have another strict global minimum, because it is the point which is in the area space. Good. So already in the same or in the context, we need the definition of complexity. What is the algorithmic complexity? It is a measure of how long an algorithm would take to complete given an input of size n. If an algorithm has a scale, it should compute the result within a finite and practical time bound even for large values of n. For this reason, complexity is calculated asymptotically as n approaches infinity. While complexity is usually in terms of time, sometimes complexity is also analyzed in terms of space, which translates to the algorithm's memory requirements. So, with the definition, we can deduct the definition of NP complete or NP hard optimization problem. So the abbreviation of NP means no determinist optimization problem. So the NP complete or NP hard or NP optimization problem are characterized by exponential or factorial complexity. Therefore, it is impossible to list all possible solutions because it is beyond the computing capacity of any computer. If it is therefore very difficult to find the optimal solution. To overcome these problems, the researchers have introduced approximate methods called heuristic and meta-heuristic. Which present the advantage of reduced fast calculation time, but don't give any information on the quality of the solution found. Among these meta-heuristics we cite the simulated annealing methods. What are the algorithms which solve an optimization problem? There are many different types of optimization algorithms, each with its own strengths and weaknesses. Some of the most popular optimization algorithms include gradient descent, conjugate gradient, Newton's methods, and simulated annealing. Optimization algorithms are powerful tools for solving complex problems. Optimization algorithms are generally divided into two categories. These are determinist algorithms and heuristic algorithms, or the algorithms which are based on random. Determinist algorithms follow a precise sequence of action, thus design variable and objectives function can have the same values and repeat the same solution routes. This is an illustration or a classification of optimization methods, or we can say specifically classification of optimization algorithms, because we are in the context of computer science. Little remarks. An optimization problem, this optimization problem, which has three contexts: the objective function, the constraints, and the variable area, is formal model. It is a formal model or a mathematical model. So because it is a mathematical model or formal model, it is a robust model because all the models which are based on the mathematical concepts are robust. We can solve them with the mathematical strategies. Okay. So this is an illustration of classification of optimization algorithms. So, or we can say optimization methods or optimization techniques, because these algorithms will be implemented in the computer. So we have first two big classes: an approximate methods and the exact methods. In the approximate methods, we have the heuristic approach and the meta-heuristic approach. You see this the prefix meta. We will define it later. So, in the meta-heuristic approach, we have three subclasses. We have the swarm population-based algorithm, like particle swarm optimization or firefly algorithm or gray wolf optimization, and etc. In the second subclass, we have the trajectory-based algorithm, like hill climbing or simulated annealing, which is our subject. And the third subclass is the evolutionary algorithm, like genetic algorithm, genetic programming, differential evolution, harmony search, and etc. For the second class, we have the exact methods, which are the good methods because they give us the optimal solution, but they take a lot of time of solving the problem, which means their complexity is NP hard complexity. So for this class of algorithms, we have two. I give two examples of methods: the branch and cut algorithm and the branch and bound algorithm. So in this illustration, our subject is this meta-heuristic based on the trajectory algorithm, which is the simulated annealing. So because the simulated annealing methods is a meta-heuristic, I take the moment to give the definition of heuristic and meta-heuristic. So in the terminology, heuristic from the Greek language means to find, and the suffix, the prefix meta from the Greek language is or means beyond or at a higher level. So meta is a prefix which comes from the Greek. It means after, beyond, with. It expresses reflection, change, succession, etc. So this prefix is a lot of use in the computer science in the different approaches or module. Indeed, a heuristic is specific to a given problem. A meta-heuristic is a generic methods that can optimize a wide range of different problems without requiring profound changes in the algorithm used. In other words, meta-heuristics are a form of stochastic optimization algorithm hybridizing with local search. The term meta is therefore taken in the sense that algorithms can group together several heuristics. So, why use the heuristic methods? Indeed, exact optimization methods can be very mathematically complex, which often results in long calculation times. So, the complexity is NP hard. And therefore, the exact optimization methods give us the good solution. The quality of the solution is optimal, but they take long calculation times, so it's not practical in the real. In practice, a solution to an optimization problem must be proposed in reasonable time, so we can be satisfied with an approximate solution. The quality of the solution is reduced, but the time or the calculation times is good, is practical. So it's good because when we want a solution of a problem, we want to practice it in the real. So if the calculation times is very, very long, so it's not practical. An heuristic is generally an empirical solution strategy that exploits the structure of problem, generally suboptimal. A solution is suboptimal, but quickly converge to a good solution. A heuristic is common sense strategy depending on the specific structure of the problem for moving intelligently through the solution space in order to obtain an approximate solution, the best possible within a reasonable time frame. What are the types of heuristic? We have two types of heuristic are mainly used. The construction heuristic, example greedy methods, which iteratively construct a solution, and the descent heuristic, which from a given solution seek a local optimum. The heuristic depends on the problem to be solved, merely in the choice of the neighborhood, therefore in the movement in the space of solution. More advanced heuristics have been developed and have given rise to a new family of algorithms, which is meta-heuristics. The goal of meta-heuristic is to succeed in finding a global optimum, which is a solution or an optimal solution. So, what is the definition of meta-heuristic? More advanced heuristics have been developed and have given rise to a new family of algorithms, which is meta-heuristics. The goal of the meta-heuristics is to succeed in finding a global optimum, which is the optimal solution. To do this, the idea is both to explore the search space and to explore areas that appear promising, but without being trapped by a local optimum. This is a principle or the important characteristic of the meta-heuristic. It is not trapped by a local optimum. We will see what's the definition of this concept or this procedure later. Meta-heuristics are often inspired by natural processes and are increasingly hybrids with other operation research methods. A meta-heuristics is generally a random walk in the search space guided by heuristics. As Candide and the meta prefix explains, these are ultra-generic algorithms with a priori apply to many different categories of problems, a bit opposite of an heuristic which remains very specific for a given problem. This illustration help us to understand the procedure of the method traps by local optimum. We have this in this illustration in the black points are the area space of solution of an optimization problem, random optimization problem. So this illustration we have the case, or we are in the case of minimum optimization or minimum function or minimum objective. So in the first figure or illustration, normally the optimal solution is this point, okay? But when we use a classical heuristic, we see that these 2 points are the local minimum, and this point is the optimal solution, which is the global minimum. So when we use a classical heuristic, we go directly in the local minimum. So the solution found by gradient descent, which is an heuristic. So we see the quality of the solution is not an optimal, it's a local minimum, because this is the optimal solution, which is the global minimum. So the heuristic or gradient descent heuristic is blocking of the classical, the title of this illustration became the blocking of the classical heuristic, which is the gradient descent, in a local minimum. So it is an inconvenient or a problem. So the meta-heuristic give us a solution of this inconvenience. And we can say that the meta-heuristic optimize an heuristic. The meta-heuristic methods optimize the heuristic methods by correct the default of this method, which is the blocking in the local minimum. So in the second illustration, we see we use another method, which is the simulated annealing method. So we can remark that these methods, the simulated annealing methods, continue its research. It's not trapped by the local optima. Sure, because in the strategy of the algorithm, they give us the opportunity of continue and evade the local minimum. So in this point, or this point is the solution found by the heuristic, which is gradient descendants, but the simulated annealing, or which is the meta-heuristic methods, continues its research. So it found the optimal solution, which is this global minimum, after a sufficient number of iterations. So this illustration gives us a comparison between simulated annealing meta-heuristic and classic heuristic, which is gradient descent. Good. So what is the difference between heuristic and meta-heuristic? Heuristic is just a solution method, often informal and individual. It is an idea from this problem, specifically the problem which is analyzed, a specific problem. A meta-heuristic is just a generic heuristic, that is to say, a heuristic which can be used to solve problems which have no connection between them. To some extent, one could say that backtracking is a meta-heuristic. The backtracking, which is an algorithm which is used to explore a tree, which is a specific graph. Good. So the backtracking or the backtrack algorithm is a meta-heuristic because we use some intelligence to minimize the space of exploring the area, to minimize the space of the area solution by some procedures. A meta-heuristic can be applied to solve a wider number of problems. In reality, when we talk about meta-heuristics, we are referring to a fairly small number of methods, such as simulated annealing. It is the oldest meta-heuristics, the taboo methods, and the genetic algorithms. Afterwards, there are other lesser known ones, such as ant-colony algorithms and etc. So, a meta-heuristics generally is a random walk in the search space guided by heuristics. As the prefix meta indicates, these are ultra-generic algorithms which a priori apply to many different categories of problems. A bit opposite of the heuristic, which remains very specific for given problems. So generally, a meta-heuristic is used for many different problems, and the heuristic is used in a specific or for a specific problem. So, example of meta-heuristics. The main meta-heuristics used to solve problems with discrete variables are simulated annealing, which explore the search space while agreeing to degrade its solution in order to exit local optima. Throughout the process, the annealing will accept this degradation less and less, which will make it converge towards an optimum closer to the global one. So, the simulated annealing methods is a local search method, which use the neighborhood, and it's a meta-heuristic because it starts with a single initial solution and gradually moves away from it, building a trajectory in the search space. Trajectory methods essentially include the descent methods, simulated annealing, taboo search, variable neighbor search, and the graph methods, etc. So, a local search can be trapped in a local minimum. Meta-heuristic can escape these minimums by constructing a solution sequence, but in which the economic function can temporarily increase. The simulated annealing methods designed to search for a global optimum among several local minima. Simulated annealing is the first meta-heuristic that has been proposed. The simulated annealing methods is a meta-heuristic which improves the local search heuristic to escape the trap of the local extrema, minima or maxima. Improvement of the gradient descent methods. For the case of minimization problem, to avoid being stuck at the first local minimum encountered, we can decide to accept, under certain condition, to move from a solution xe to a neighboring solution xe plus 1, which is in nxe, the space nxe of neighboring, despite the fact that the economic cost function increases. So we have fxe plus 1 is more than fxe, a smarter route. As to certain meta-heuristic methods, such as the taboo methods, this is deducted from the principle of proverb, give up in order to move forward. So, in my reflection, every algorithm or any algorithm or an algorithm is an idea to solve the problem. This idea is an origin of wisdom. A lot of proverbs are the base of many algorithms. Example, give up in order to move forward, or separate and conquer. So, because I use and implement different algorithms, I deduct that every algorithm is a reflection of the conceptor or developer of the computer science. This idea is explained in the algorithm, which we must respect the concepts of an algorithm and effectively they must be implemented in the computer machine. So, what is the origin of the simulated annealing methods? The simulated annealing methods is an optimization algorithm. Historically, the simulated annealing methods take its name and inspiration from practices derived from thermodynamics and more particularly from the way in which metals are heated and then cooled. In metallurgy, the annealing of the metal parts is a process corresponding to the heating cycle. It is the maintenance of temperature, then controlled cooling, allowing the characteristics of this metal to be modified. So, originally, the atoms that make up the metal are caught in a solid crystal structure. When the metal is heated, the available energy allows the molecule to break their chemical bonds, giving the atoms their mobility. In the metal is cooled slowly, terminal mobility decreases and the atoms seek to form new bonds. Surprisingly, they are often distributed more regularly compared to their initial configuration. So, chemically, the stability of the metal is due to the arrangement of the atoms and the fact that their respective states then reach an overall minimum energy. If everything is done according to the rules of the art, the metal became pardon the metal becomes softer, more flexible, and has fewer irregularities. Otherwise, if the metal is suddenly cooled, it reaches an unstable polycrystalline state of higher energy, allowing the characteristics of the metal to be modified. Originally, the atoms that make up the metal are caught in a solid crystal structure. When the metal is heated, the available energy allows the molecule to be stable. The heat of the process is thus slow cooling, allowing sufficiently long time for the atoms to redistribute themselves as their mobility decreases. Physically, the natural energy minimization mechanism relies on the Boltzmann probability distribution. This is the equation of the energy. PE it's less equal to exponential this expression. Good. So, what is the application area of the simulated annealing meta-heuristic? As with any meta-heuristic, the simulated annealing methods can be applied in the many optimization problems. Researchers have used it mainly in the design of integrated circuit, problem of placement and distribution, the packet routing in networks, image segmentation, the traveling salesman problem, the backpack problem, the artificial intelligence, and etc. In this moment, I give a little bibliographic history. This is Metropolis, which it is Monte researchers, which is name Monte Carlo methods. Yes. So I will take a moment because the image. Yes. Good. So in 1953, the simulated annealing methods carried out by Metropolis and R to simulate the evolution of this physical annealing process. Monte Carlo methods are a class of numerical algorithms that replay one-off repetition of random sampling to estimate their results. In 1983, it was developed by three researchers from the IBM company, Kirkpatrick, Gillette, and Vichy in the United States, and independently. In 1985, by Cerny in Slovakia, the use for solving combinatorial optimization problem is much more recent. This is the photo of Metropolis, which is the basic idea of simulated annealing problem. Idea of the basic the Metropolis strategy is the basic of the simulated annealing methods strategy. So, the simulated annealing methods is inspired by the thermodynamics of the system of particles. Annealing is a process used in metallurgy to obtain defect-free law. At very high temperatures, the metal is in a liquid state and the atoms move freely. Cooling is carried out to return to the solid state. If cooling is rapid, winking, the atoms freeze in a disordered, irregular state. The law obtained has an irregular structure and represents defects. So, when we use a high energy in the cooling, if the cooling is slow, annealing, the atoms rearrange themselves regularly. The resulting law has a flawless crystalline structure. So, we have a minimum energy. So, what is the difference, or how simulated annealing use the principle of the metallurgy concepts. So, in metallurgy, metals have unique properties, in particular thanks to the behavior they adopt with respect to temperature changes. One of them is annealing, where the metal is first heated and then slowly cooled over time. Through this process, the metal becomes less hard and ductile. In computer science, programmer took note of these unique properties and brought them to their file, giving rise to the simulated annealing algorithm. It is used to find a global optimum for specific problem and works like metallurgical annealing by gradually reducing the temperature. For the algorithm, the probability of moving towards a less good solution. It means this. This is a dynamic illustration of the metal, the structure of the metal in metallurgy. And this is a figure or an illustration, a graphical illustration of the process of simulated annealing algorithm. So, the title of this illustration is, at very high temperature, the metal is in the liquid state and the atoms move freely. But we see that these atoms and there are dynamic. They move freely. When we take a high or we have a temperature change, the metal take its form. And this is a process of the simulated annealing algorithm. So we see the temperature is, we have little values of the temperature, and in the final value of the temperature is 0. We or the algorithm, the simulated annealing algorithm, obtain the optimal value, which is this point, because we have, or we are in the maximization case. The objective function is a maximization. You see, we have 0 and the maximum. Good. So, simulated annealing iteratively applies the Metropolis algorithm to generate a sequence of configuration which tend towards thermodynamic equilibrium. By adding the temperature parameter, we give ourselves the chance to escape the local extremum and to control the acceptance of degradation of the cost function. We don't go through all the laws in case of minimization. What is the Metropolis algorithm? The Metropolis algorithm is, or in this algorithm, we start from a given configuration, an initial solution, and we make it undergo a random modification. If this modification reduces the objective function or energy of the system, with the terminology of metallurgy, it is directly accepted. Otherwise, it is only accepted with a probability equal to We take E, it's the energy, and T is the temperature, so we have this expression. And here I take the equation, or I give equation of delta E and delta F. In the difference between the previous energy and the current energy, we have this difference. In general, energy is our cost function. This rule is called the meta-heuristics criterion. This is an illustration of the algorithm globally of simulated annealing process. The students can take his time to analyze this illustration, because I put this presentation support in the Moodle platform, so the student can revise it and see or try to understand the principle of the methods. So, simulated annealing is an iterative algorithm that uses the meta-heuristics criterion. We have two nested loops. The first loop to lower the temperature, thermodynamic stability. It is the mean, or its mean the thermometer. We use the temperature, which means the thermodynamic stability. Change. So the first loop to lower the temperature, change the value of the temperature with the aim of converging towards a global optimum, global minimum for the case of minimization problem. The second loop to choose the best neighbor of the current solution using the meta-heuristics criterion. So this is an algorithm, or the listing of simulated annealing algorithm, which in the technical with the technical words, we say it's an optimizer. It is software which implements this algorithm. So in the terminology of software, this algorithm is until an optimizer. When it is a program, is an algorithm. We translate this algorithm in the program with any programmation language, example Python. So we have a software which is the optimizer, because it solves an optimization problem. So I give another form of the algorithm with the flow chart. It's so visible and clear. So there are the different steps of the algorithm. Firstly, we randomly generate the initial solution x0 and compute the objective function fx0. And secondly, we generate the new solution x new and compute the objective function fx new. We compare between the f de x new and the fx0, which is until delta f. If delta f is inferior or equals to 0, we accept the new solution. If not, we accept new solution according to Metropolis rules. Whether the number of iteration is get, so we must in the practical give maximum number of iteration which the algorithm or the program can take or make in his execution. So if we have yes, so whether the condition is met. If it's no, we return to the generate a new solution, a new neighbor. So if it's no, in this case, we decrease temporal slowly, reset the number of iteration, and return. If it's yes, the test is valid. So we return, or the algorithm return the optimal solution. Good. Donc the students can take his time to see this flow chart and try to understand these steps of the algorithm. So each algorithm have parameters which are very important. We say parameters or hyperparameters, because they have they can change the results if we change their values. In its standard form, simulated annealing has two parameters, namely the initial temperature and the cool down factor, which is alpha. The temperature T is the list of positive real number. The temperature makes it possible to control the acceptation of the solution or not by calculation of the metropolis criterion, which is this. The value of the temperature parameter varies during the search for iteration. At the beginning, T is large, metal is liquid state in the metallurgy. It gradually decreases to reach the value 0. So the metal is solid. In this case, I use the term in the computer science. So the beginning value of temperature, which is T, big T is here, it is a numerical value. In the metallurgy, that means the metal is liquid state, is in liquid state. When we gradually decrease the temperature to reach the value 0, so the metal become solid metal. Beta is parameter which mean the test of the probability of accepting the solution or not. X0 is the initial solution, T0 initial temperature, very high in the first, and then it decreases to reach the value 0. And we choose a stop test. So now this is an important parameter. For the stop test, there are a lot of stop tests. We can take it when we analyze our project or our problem, and we can decide what is the or how we can define or define this stop test. Now I give a resume of the artificial intelligence and simulated annealing. Artificial intelligence, abbreviation AE, has made remarkable progress in recent years with advances in machine learning, natural language processing, and computer vision. One of the main factors contributing to this progress is the development of optimization techniques that allow AE systems to learn and adapt more effectively. Among these techniques, simulated annealing has emerged as a powerful and versatile approach to solve complex optimization problems. One of the main advantages of simulated annealing is its ability to handle large and complex search spaces, making it particularly suitable for artificial intelligence application. In machine learning, for example, simulated annealing has been successfully applied to train neural networks, optimize hyperparameters, and select features for classification and regression tasks. By efficiently exploring the vast space of possible model configuration, simulated annealing can help identify the best performing models and improve the accuracy and generalization capabilities of machine learning algorithms. In natural language processing, simulated annealing has been used to solve, in natural language processing, which is an area of artificial intelligence, simulated annealing has been used to solve various optimization problems such as text summarization, machine translation, and sentiment analysis. In this application, the algorithm helps find the optimal combination of linguistic features, rules, and parameters that maximize the performance of the models. In conclusion, simulated learning has become a powerful and flexible optimization technique for artificial intelligence application. By efficiently exploring the solution space and gradually refining the search process, the algorithm can help solve complex optimization problems and improve the performance of artificial intelligence systems. So I take in this presentation, I give an example which is taken from the reference 13. So to better understand the algorithm, we use simulated learning to illustrate the minimization of this function. Okay, with this equation, we use a search space, a grid of size 101 with 101 place in the square area defined by this equation. We set the cooling rate alpha is equal to this value, and the initial solution is x, y, which take the value 4, 4. At each step, a new solution is generated by randomly shifting the current solution by this value in x and y direction. Here's an animation showing the candidate solution, its energy, and the temperature at each steps. So we see this is the candidate solution. In the red with the blue, it's the current blue point is the current solution. The red point is the exact solution or the global minimum, because we are in the minimization case. So we see here the decrease of the temperature, and here the evaluation of the energy, which is the value of this function fgx and y, because we have two variables. So we see that we have the change of the energy, and in case we see that the energy can take not good value, but it is the objective to attain the global minimum. That means it's this strategy used this adverb give up in order to move forwards. En français, renoncer pour avancer. Donc on accepte des valeurs de la fonction objective qui sont moins bonnes dans le but d'atteindre la solution bonne. So I continue. For the practical case, because I implement this algorithm, the simulated annealing algorithm with Python, so we will see the results with Anaconda Navigator, which implements Python. So for the application or application example, I take the application of simulated annealing algorithm to the TSP problem, which is the traveling salesman problem. It is the traveling salesman problem, or abbreviation TSP, is widely studied and is the subject of several studies or searches. Well known in the field of combinatorial optimization and operation research. It remains an NP-hard problem with exponential complexity. It is a model that represents a significant number of real problems. The objective is to solve the TSP in a reasonable calculation time and with better solution quality. There are many approximate or approximation algorithms for the resolution, such as the meta-heuristic simulated annealing methods. So for every or any developer or computer science, when he use algorithm or when he program algorithm, he must give the importance to two problems: the calculation time or the complexity of the algorithm, and the quality of the solution. So our objective is to give a better or a best solution, the optimal solution, the best solution, what is good quality is where it is optimal solution, and in the reasonable calculation time. That means with the minimum complexity. Because when I give, or my solver or my program give a good solution, but in a big time, it is not it's not our objective. Donc there are many approximation algorithms for this for the resolution of TSP problems, such as the simulated annealing methods. So what are the area of this problem, because it's important? What are the area of application of the TSP problem? There are a lot of area. The area of application are numerous. Example, logistic problems, transport of both goods and people, scheduling problems, planning problems, in industries such as the optimization of machine tool trajectories, how to drill several points on an electronics card as quickly as possible, and etc. So this is a description of the problem and its illustration. A traveling salesman problem must visit, or in this problem we have a traveling salesman which must visit a finite number of cities once and only once, and return to his starting point. We want to find the route to visit the cities, which minimize the total distance traveled by the traveler. In graph theory, the traveling salesman problem consists of calculating a minimum cost Hamilton cycle energy. We will solve the following TSP using the simulated annealing algorithm. So this illustration of the TSP is a graph with points, and points are interconnected. So solving a TSP amounts to identifying all the possible paths to visit all the cities once and only once, and calculating the distance. The solution is obviously the path with the minimum distance. For n cities, the number of possibilities is equal to n factorial. We consider the symmetry of the S, because in the other cases we can not consider this symmetry. So for n equal to 5, the number of possibility is to explore is 5 factorial. So we have 120 paths. For n equal to 10, we have 3 million possibility paths. For n equal to 20 cities, we have this big number, or these big possibilities of paths. So an exact method becomes very expensive to solve this TSP in the calculation time. It gives us a good quality of the solution. It is an optimal solution, but it takes a big time to resolve this, which is not particle time. So we use the meta-heuristic methods. The traveling salesman problem is of non-polynomial complexity, a problem that we call NP-complete. This is why the use of an approximate algorithm or a meta-heuristics become a necessity. The solution is not exact, it is approximate, but the calculation time is reasonable. As a result, the traveling salesman problem has been and continues to be widely studied due to its complexity and the large number of derived problems. There are numerous approximation algorithms. Each has its advantages and disadvantages. The methods chosen will not be the same depending on which one favors the calculating time, the quality of solution, or the choice between several solutions. So why use simulated annealing algorithms for TSP? Simulated annealing can be applied to to the traveling salesman problem. The goal is then to find the Hamiltonian circuit. The Hamiltonian graph is a graph having at least one cycle passing through all the vertices once and only once. Such an elementary cycle is then called a Hamiltonian cycle of minimum cost in a graph. Energy will represent the total distance to be traveled, and a state of the system will represent the path between cities. The algorithm will therefore try to minimize the total length of the path by modifying an order of the cities to travel through. When I implement this algorithm, this is my environment. So the environment of the work is Python language, programmation language with Python version 3.10, which is a powerful language ideal for scripting and fast application development in several fields on most platforms. The library used, we will see them in the implementation. I use Jupyter Notebook was chosen, which is an interactive computation environment. The computation were carried out using the HP laptop with an Intel Core i5 with 2.60 gigahertz CPU and 4 GB of RAM. The laptop runs on the Windows 10 operating system with 64 bits processor x64. The meta-heuristics will test the random instances. So what are the choice, or what is the choice of the algorithm parameters? I set the number of cities to 5 so that the calculation time is not too long during the development phase in this video. So we have n equal 5 in the number of cities. The temperature parameters are declared with the initial temperatures, minimal temperatures, the parameter tau or alpha. The choice of the initial temperature and minimum temperature values, the one which determines the end of the Annealing program, requires several tests. Generally, the value of T0 should be large, make the metal liquid. The value of tau must be chosen large enough so that the decrease in temperature is sufficiently slow, but not so large as not to have too large a mass of calculation. Of course, we can always modify these parameters to check their influence on the results. So this is some bibliographic references which I use to prepare this presentation. So I go to the practical tutorial. So the implementation of the methods. So I use Anaconda Navigator, which it is the support of Python, and I use Jupyter Notebook. There are a lot of notebook software, but I prefer this software, which is Jupyter Notebook. So I already execute this notebook, and so I have this interface of the Python. So I upload my program, which is named or entitled algorithm. So it is not important. Which is named until algorithm Q analysis algorithm Q simile. So I upload it. It is this. It is the program. This is a number of libraries I use. The NumPy library. Excuse me. The sum of libraries I use. There are NumPy library, matplotlib library with the module pyplot, and the random library. So I execute this sailor. So the library is uploaded. I execute my algorithm. This is the body of the algorithm of the program. Okay, I use different instruction in Python programmation. I have listed here the iteration. So k equal 0, it's an initialization, and it's take number of iteration. So I have k equal to 11, so it's the maximum number of iteration. So I have the final root. It take the number of the cities, and the optimal distance, it's this value. This is the illustration of these points are the cities, and their interconnection are the roots. This is the illustration of this solution, of this trajectory. Okay, so this is the end of my presentation or my lecture. So thank you for your attention, and if you have any question or comments, we can take it or make it in the comment area. Thank you.